So hi everybody, my name is Aidan O'Connell. I did try ChatGPT and AI to give this presentation, but unfortunately you have to deal with me in person. So just to give a little background of who we are, for those of you who don't know us. So as I said, Aidan O'Connell, Punch Consulting Engineers, in the industry for the last 20 odd years, loads of scars to prove that. There's still a lot of blank canvas yet for more scars to learn as we go along. Work for a company that's, this one I think works, does it? Yes. So work for Michael Punch Partners. They're around for the last 50 years. We have offices in Limerick, Cork, Galway and Dublin, office in Glasgow and another one outside Macclesfield. I've worked both in the Irish and the UK market. We have 130 odd staff and we've worked in everything from residential developments to £180 million developments. And actually, David Conway's presentation there, if you saw it earlier on, Opera, Hanging Gardens inside in Limerick and the International Rugby Experience are recent jobs that we carried out with them. So we have a good bit of experience in the civil structural thing, even though we're a multidisciplinary organisation. I'm mainly structural and that's what leads on to the bonds and how we did the bonds, I suppose, really into it. So traditionally, so the bonds is a £190 million development. It's a hospital on the outskirts of Limerick, for those who don't know. It's a 4-storey building. That's a small portion of the bonds, probably half of it. And we were the civil structural consultant engineering firm delivering it. So one of the things that's kind of interesting, and you can see there on the right-hand side of the picture, is there's a nice 2-storey, 6-metre cantilever hanging off the end of the building. So, as you said, I make architectural dreams real. Cringe to that, but as you can see, the structure underneath is quite robust in order to carry that and for the life of the building and design it out, which made it quite complex. So when we were looking at this and scheming this up and getting the efficient models, and he was going through all the relative QSs things, it came to apparent that putting the reinforcement into this building would be quite challenging because it's also curved on plan. So we took the decision within Punch to develop this into a 3D reinforcing model. Nothing relatively new. There's packages out there with a number of years that kind of do this, but it was our first venture into the 3D modelling and reinforcement, really, rather than a traditional AutoCAD, CADS RC. And mainly, we haven't really delved into that a whole lot only in the last couple of years because of commercial reasons, because it's not always applicable to do this. So this wasn't asked by the client, and it wasn't asked by CISCs in order to do this, but we did see the advantages on it. So traditionally, we would, you do your Revit model, you do your analysis, and this talk is about the steps that we carried out in doing this. So we use Tekla Structures Designer to do the 3D modelling. Now this is a different building, it's ICT in Maynooth, but we've been doing this process for a number of years and most consultancies are doing the same. You develop on Tekla Structures, that gives you the output recently of all reinforcing drawings that we can use. We then gave that then to our Tekla Structures team who were developing up the reinforcing and 3D model in that platform, then more so than the CADS RC 3D platform that's out there at the moment, which we are looking into as well to see, because ultimately there are 2 different licenses, 2 different cost points, 2 different pros and cons. So we're evaluating that at the moment to see what's the best way of doing this. Just like to say from the outset, we don't do 3D reinforcement in every job, because it's just not viable to do it for the price point that we're at. The market's at more so than what we're at. So as you can see here, the coloured building there was done in another analysis program called CitA, and then that was imported into Revit, and the guys in Revit brought the model up to Revit standard, where you produce your PDFs and drawings and all that sort of stuff and reinforcing, and then that's given out on site. We went a little bit step further with the bonds. Sorry, that one, yeah. So I'll just play it here. It's a little video in that's the model. So you can see the deep beams underneath there, and to give you kind of an aspect, they're roughly around 1 metre deep. So they're from your, they're quite sizable structure to carry stuff overhead. That's the beam is done in 3D and reinforcing. And the reason we took the choice to do this is that you have 2 beams overlapping. So the video doesn't really show that well. Maybe the pictures will later on. Is that it's very, oh yeah, I zoom in there now. There's very congested reinforcement there. And trying to integrate that onto site, given to the fact that we talked with CISCs and they were prefabricating a lot of the beams on the ground and then lift them into place, it had to be manufactured and detailed a certain way so that when it lifted into place, the tolerances were there between the layers of steel, given the congestion that was there, that it would fit. Because it's lifting a crane takes time will be lost. So we spent a bit of time with CISC in coordinating that, and then we gave them that bit of information. We sat down with the model with them, gave them access to the model through a Trimble Connect platform. And then we went through how we were piecing this together, how to stitch it. And that fed down then to the steel fixtures and how to make the beams on the ground to be lifted via crane into place and thread the whole thing through. And again, as I said, we did that because we saw the issues earlier on that would happen if we didn't do that, which would lead to, I don't know if there's many structural engineers here now, you're pulling this rebar out, taking this link, lifting it out, pulling it down, creating the gap, lifting back in. All of that's just delay, aggravation, that's not needed. So that gives you, the next slide, gives you a kind of an indication of how congested it is. So we gave that model to CISCs, we talked them through it, they lifted into place, and everything went relatively smoothly, I have to say. But we went back then to see what was the benefit of giving them this model. Like, is it just a selling point, a USP? What was the functionality of it? We saw it, but in fairness to CISC, they saw it as well. They were under, it's not contractually, they were on a tight program to get this over. They can't afford to be losing days. But there was other spin-offs from it as well. The young engineers who wouldn't be, I suppose, au fait with reading reinforcing drawings on site use this tool to understand the drawings in 2D a lot better. And so they got a faster education on how to read drawings on site and how to check that everything was being made properly on site and fit. So that was kind of, and there was loads of other spin-offs that they used. Like when they got into the model and got using the model, they saw the benefits for it. And look, visualization is the best way of absorbing information. That goes without saying, rather than a 2D drawing. So one thing we kind of lose in all these AI and platforms and 3D models is actually perspective. What exactly am I talking about? Okay, you had a beam going through a beam, you got the reinforcement fitted to site. But that's the beams there. That's a guy down on his knees tying the reinforcement. That's the reinforcement he was fixing. So like that issue was really only really identified how to do this and get it to fit right in the 3D model. But the guys on site, like you lose touch to what you're doing. You see a model, you don't really realise what impact this has. That guy has to physically tie the reinforcement, pull the reinforcement through. He's the guy on the ground. He's the guy going to be using the sledge if it doesn't fit. He's the guy that's going to spend an extra day fitting the reinforcing. So by us making that decision, we made his life easier. Does he know that? No. CISC got the benefit of it, the client got the benefit of it. We actually got the benefit of it because we weren't spending an extra day or 2 days out there trying to fix it. The guy on the right-hand side there is Pat. He was the happiest steel fixer in Limerick that day when the whole thing was fitted in. So I don't know if you can see his smiley face or not, but really nice man, I have to say. So that was kind of our first foray into 3D reinforcement and why we'd want to use it. But it wasn't our first foray into 3D modelling. So we are doing MMC work with Kilsarn. And again, it's kind of like the same process. So I'm going a little bit off of bonds, but it's going through the process is what the interesting part is here. So that's a Tekla structure model that we detail up. It's a residential apartment block. Put the windows and door ropes and all the beams, where the beams need to go, the size of the beams, all that information is contained into that when it's designed, developed. Then that feeds into the Tekla structure model, which you're seeing there. And again, they use the Tekla structure designer model to infer where the structure is going, the depths and the sizes, how it's framed out, the span directions of the slab. That all feeds into that. So it's going from one digital platform into another. You're not marking up stuff and delaying and inferring and the details. That doesn't come into play. Then when you go into the manufacturing side of things, and we kind of see there, I can't really, can you pause? Every part of the building is reinforced. So last year we were doing all the wall panels reinforcing, nothing new in the precast industry to be fair, maybe in Tekla structures, but it's been fed into a robotic factory, which kind of feeds into the AI that we're talking about here. The information has to go to the robots in a certain way for them to make it. On top of that then is that we decided like what was happening on site and what we were finding is that, you put in the hollow core, it all fits because it's robotically made and there's no clashes or anything like that. The screed reinforcement, the tire reinforcement was all being done in 2D. So then there was a time lag that if there was a change in the model to doing the stuff on Autodesk, there was 2 or 3 days to develop the drawing and these buildings go up relatively quick. You can't afford that, and it was ineffective. It was actually costing us money to take stuff out of Tekla, do it up in AutoCAD, the reinforcing for the screeds and the tire reinforcement between all the panels, and feed that to site. And if there was a change, you have to go through that whole process again, which is a complete waste of time and money. So we then started investing into developing automation tools within the Tekla structure platform to develop this better, to automate the drawings, generate the drawings, so it's a live model. Not only that, the guys on site that are fixing the reinforcement have access to the model, so they can see how the reinforcement fits and everything fits, and you can carry out clash detections, you can go all into it. So we now have a model that if the steel members, we do the shop drawings as well for all that by the way, we now have a model that has everything in it. So a contractor has one model with steel, one model with precast, all integrated, one supply chain. So he's not trying to integrate little bits of steel, little bits of hollow core, little bits of walls with 3 subways and doing clash detection. So we purposely did that to speed up construction, make our life easier. There's no mistakes on site. So there's less time for us doing corrections on site, and the contractor gets the benefit to see what he's getting, how he's building it, and obviously Qatar get less issues on site, and they do go up quite relatively smooth. So that let us go back to the bonds, and we said, let's try it on an in situ building, and that opportunity came up when we tried it on that. But what we're finding is that one thing that's not talked about here a whole lot is the AI and implementing it, and you kind of touched on it there, Paul, a little bit, is that like there's a commercial side to all of this. And normally when you try something new, you'll be floundering around is probably a phrase you could use, and it's not cost effective. So you try and follow the other people to find out the mistakes they made so you don't make the same, to make it viable. Margins in construction are small. Like, we're not all going to be driving Porsches and Ferraris anytime soon. And one thing I'd see now and again in my research is that they're saying, oh, the industry is slow to pick up AI and pick up this, which is totally, like, it's not a fair indictment of the construction industry as a whole. The reason they're slow, it's not that they're slow, is that commercially it's not there. So what we will find is, and what we are finding is that the more complex the building, the more applicable it is, because there's, and the industry sector you're in, the more applicable it is. So take, for instance, data centers. Nice margins, huge margins. I don't know, I didn't work in data centers, I'm told this. Logistics buildings, pharmaceutical buildings. All this construction advancement we're talking about here, about digital twins and asset management and AI, construction industry, honey, has maneuverability inside in the profits that they're making there to implement all this stuff. And then that will trickle down to the low-hanging fruit, like the residential sector and stuff like this. That's my opinion. I'm not saying it's written in stone, but I do think that is the biggest hindrance to the industry taking up this as a whole, unless, as Paul said, we're not going to be investing in creating our own platforms, because medium to low firms don't have the budget to do it. The bigger firms can, and they will. And in that, we have to buy the license on it, and you have to make it commercially viable. There's a price point, there's a market, there's a margin. The roof is set, the ceiling is set, and you have to work within that. But there is small advancements to be made. So, for instance, in Punch, we've set up an innovation group. It's running for now for about 2 or 3 years. And small gains, automatic generating of drawings, automatic dimensioning tools that needs to be done, and sections generated. All that sort of stuff is all very, very good, which came to the fore on the bonds. We spent a lot more time on the reinforcing, but the platform we used allowed us to extract all the rebar drawings relatively automatically. So the time we spent on coordinating it, we got it back off the drawings, and that's how we made it commercially viable, and that's the only reason it was commercially viable. So a lot of the things you'll see up here, we have done. So, automated clash detection, BIM, Navisworks, we're all kind of very familiar with that. That's where we're all comfortably at the moment. Incorporating the AI into that, from what I'm talking to people here, a lot of people are hesitant because of the legal ramifications, monitoring your data and all the rest of it associated with that. So I don't see AI in my, I suppose, business as Punch Consulting Engineers changing what we do drastically over the next number of years. Could be totally wrong there now, to be fair. Time will tell. But obviously it has to be commercial viable. One thing I do see, though, that I think is the next steps and what I'm reading is augmentation, mixed reality, looking at how things are fitted on site, they're in the right place, they don't clash with something else down the road. I do see that coming in fairly soon into the engineering spectrum, in engineering form, and it could be something as simple as an RE out in site doing inspection of structures or M&E work, whatever the case may be, that their role would develop into carrying out these tasks that would feed back live realignment of pipes or realignment of ducting, or column is in the wrong location, or and you'll see there like 2 companies up there. So you've Trimble and an XYZ company, because one thing I am finding hard to guess is information. How much saving are you making? Are you actually making saving? How are you measuring that saving? Is it worth implementing the stuff, or is it not? That information didn't readily available out there, and what it's been used for. So that's, if someone wants to hit me up with some good case studies and structural and civil stuff that trying to implement, please email me. I'd be delighted to get that info or that link. But I do see that in engineering, now this may be more main contractor than consultancy firms, that for mixed reality especially, in the right sectors, like I said, will be implemented relatively soon. It's already out there. As I said, there's 2 companies there. I just kind of, you read and you go through LinkedIn and all the rest of it to see what they can do. I find they're interesting in what they're doing and how they're making savings, how they're quantifying savings, and what savings they have. So they're doing case studies, and ultimately that's the litmus test. If, as I said, they're the trailblazers, we're following them to see if they can, what they're doing right and what they're doing wrong. But we'll be buying, we'll have ultimately have to pay for this software, have to implement the software, and we have to get the investment back. And whether the market is able for that or not is another question. That's just a collage of jobs that we're working in, just to give you a flavour of what Punch Consulting is done. I know the bonds was a specific industry. As I said, we are now looking at Tekla and CAS-RC for 3D reinforcement and how we're going to implement that in design construction. I think the link between analysis and Revit and Tekla, whatever platform you use for drafting, that's already beaten to death by a lot of people, so that's information is already there. It's the next step, but 3D, but not 3D in a platform, 3D actual on site and the as-built implications of it on site. If a beam is 50 mil one way, how does that impact on your reinforcement? That sort of stuff. For steel beams being detailed and now it's 100 mil longer, that you're not getting a whole lot of RFIs and clash detections coming down your way that you have to spend time to sort on. If you can sort this real life on site at the time, then maybe there's enough saving there for us to implement that stuff. But Punch only started the journey. Innovation Group do small little gains, and we'll see where this AI stuff will finish up in the next 20 years. As I said, I started off with faxes, and now we're talking about AI. It's crazy, really, think about it. Dave Conway talked about his daughter starting off in Trinity and building the whole thing up. Like, God, she doesn't know what a fax is. Will she know what a PDF is? Who the hell knows, But it's interesting, and it's moving at pace. Like, you think about it, you took the recession out of the construction industry in Ireland, that's maybe 8 years into 2008 to 2024. You're nearly half that cycle because of the recession, everything shut down effectively. So in less than a decade, we've gone from, the starting of BIM, which we did back in 2006, to where we are now. So, and go back to that statement about the construction industry not adopting software and technology for the improvement of people's lives and social and getting all that integrated, that just goes against my grain a little bit. I think we should be giving ourselves more of a clap on the back for using the stuff rather than being shot down every which way we turn. All right, thanks guys.
Thanks, Aidan.